How long is 22.1 kilometers? If you were to stand it on its end, it would be long enough to stretch from the peak of Mount Everest all the way down to the deepest part of the ocean, or to drill straight from the surface right through the Earth's crust. And that is the exact length of the world's longest expressway tunnel. This is the Tianjin-Xingli Tunnel, located in Xinjiang. On December 26, 2025, the entire line will open to traffic, which means that for the first time, the Chinese have punched a highway straight through the Tianjin Mountains. And we had the honor of partnering with Kiknev and China Communications Construction Company to witness this historic moment. But just how difficult is it to build an expressway through the Tianjin Mountains? What exactly happened thousands of meters deep inside these mountains? If it were you, how many of these challenges could you overcome? Welcome to the Planet Research Institute and our new creations of Heaven and Earth series. What you're seeing now is a gap in the ridge of the Tianjin Mountains, but it wasn't formed by nature. Over 60 years ago, people used tons of explosives to blast this mountain pass into existence with sheer force. It's known as Tiger's Mouth, and only by doing this could National Highway 216 cross the Xingli Daban of the Tianjin Mountains, becoming the first road to connect northern and southern Xinjiang. However, the winding mountain road turned what should have been a straight-line distance of over 250 kilometers into a detour of nearly 400 kilometers. In winter, heavy snow would close the mountain, making it extremely dangerous. Even if you chose to avoid the mountains altogether, it would still take over 7 hours to travel between the two major cities of Urumqi and Korla. In the eastern part of the country, that's enough time to drive from Beijing to Jiangsu. Want to go faster? The only way is to go straight through the Tianjin. However, the location for cutting through the mountain couldn't be too low, or you'd face an incredibly long tunnel. But it couldn't be too high either. Otherwise, you'd still have to deal with steep climbs and winter snow. After weighing all the options, the engineers finally decided to build a 20-2.1 kilometer long tunnel here, longer than China's previous record holder, the Qinling-Zhangnanshan Tunnel, by a full 4 kilometers. But choosing a length like this also meant that people were destined to face one immense challenge after another. First of all, the time it would take to break through was simply too long. Using only the traditional drilling and blasting method, even working from both ends, it would take at least 10 years. If they used auxiliary adits or inclined shafts to work on different sections simultaneously, they could speed it up to 72 months. So, the engineers decided to go even faster. Between the two main tunnels, they first built a central pilot tunnel, also known as a parallel pilot tunnel. By connecting to the main tunnels through it, it was much more convenient than digging adits or inclined shafts from the steep mountainside, and the distance was also shorter. As a result, the 22.1 kilometer long tunnel was gradually divided into 15 sections. At its peak, there were even 14 work phases being constructed simultaneously, a true case of building a marathon tunnel at a sprinter's pace. But all of this depended on the central pilot tunnels, excavation progress being faster than the two main tunnels. So how did they achieve that? This is where China's independently developed Tianjin and Xingli hard rock tunnel boring machines came in, TB-MIS for short. Their cutter heads, with a diameter of 8.43 meters, can crush solid rock. It is 3 to 10 times faster than the traditional drill and blast method, making it perfectly suited for excavating the pilot tunnel. Meanwhile, the two main tunnels have a diameter of up to 14 meters, far exceeding that of common TB-MIS. Thus, they are more suitable for construction using the traditional drill and blast method. In the end, after 52 months, people successfully broke through this 20-2.1 kilometer ultra-long tunnel. The transverse pilot tunnel was also preserved, becoming a passage for emergencies and rescue operations. However, these 22.1 kilometers were not all smooth sailing. When you cut open the Tianjin Mountains, you'll discover that their body is incredibly fractured. Before you are 10 different types of rock and 17 fault zones of varying sizes. Among them, the largest, the Boa Fault, is an astounding 460 meters wide. It single-handedly separates the northern and central Tian Mountains, faced with such a fragmented, uneven mountain body that alternates between soft and hard. Conventional T-beam is designed for solid rock formations. Were no longer up to the task. This meant engineers had to perform an unprecedented upgrade for the Tianjin and Xingli machines. In conventional mode, they can rely on gripper shoes to firmly brace against the solid rock walls on both sides to gain forward propulsion, and unlike shield machines commonly used in soft soil, they don't require additional support. But when encountering the difficult mode of softer, more fractured rock layers, they could first erect steel formwork and then fill it with concrete to stabilize the cavern. And when encountering the hell mode of extremely deformable and fragmented rock layers, they could provide support just like a shield machine, but using steel, which is much stronger than concrete. Even when encountering danger in the complex geological strata. People could use the pilot tunnel route to bypass to the front of the cutter head and complete emergency rescues. In the end, the Tianjin and Xingli machines, moving towards each other, would connect with precision, breaking through the entire pilot tunnel. Meanwhile, in the main tunnels, engineers chose to overcome hardness with softness. In an unprecedented move, they filled nearly 40,000 pay pipes with foamed concrete. Then they wrapped them around the cavern's surface, forming a 70-centimeter thick shock-absorbing layer. Furthermore, in the reinforced concrete that was subsequently laid, they left a 1-meter wide gap every 30-plus meters. This allowed the tunnel structure to be as flexible and pliable as a nunchaku, significantly reducing the impact of fault movements on the tunnel. However, even if the ultra-long tunnel could be successfully completed, people still faced a major challenge: ventilation. If fans were used to supply air directly, the maximum ventilation distance would only be about 5 kilometers. This meant that engineers had to find a way to drop 4 sets of ventilation shafts down from the mountain peak to connect the 2 main tunnels, thereby dividing the 22.1-kilometer-long tunnel into 5 sections to be ventilated separately. The deepest of these shafts would reach 707 meters, several tens of meters taller than China's tallest building. If it were you, how would you dig such a deep vertical shaft? The engineer's answer was to turn a TBM upright. As its name suggests, this is the world's first hard rock ... vertical boring machine, the Shochuang. It combines TBM and oil drilling technology and can directly bore a deep shaft with a diameter of 11.4 meters, all while operating unmanned. Yes, today we no longer need the tragic sacrifices of heroes when mountains collapse and the earth gives way to connect sky ladders and stone trestles. However, even with the Tianjin Xingli Tunnel, it is already 22.1 kilometers long. Yet the tunnel entrance remains at a high altitude of around 3,000 meters. This means it must also face the challenge of low temperatures. As the old saying goes, snow on Tianjin Mountain in May. No flowers bloom, only the cold remains. Near the tunnel entrance, the average annual temperature is only -5.4 degrees Celsius, with the lowest temperatures dropping below -40 degrees Celsius. If the tunnel isn't insulated against the cold, ice formation could affect road conditions and even damage the tunnel's structure. You might cleverly think of adding an insulating layer near the tunnel entrance. Well, you're not wrong. But the engineers also had to install a heating system for the tunnel. They discovered that the temperature deep within the mountain is essentially constant. So they drilled 80 meters down, deep below the permafrost layer. That's a depth of nearly 30 stories, allowing them to use the Earth's natural temperature as a heat source. Then, by running heat exchange pipes through the tunnel's lining, they could achieve stable heating. So, how many of these challenges did you manage to figure out? In reality, the builders had to face waste disposal, wastewater treatment, ecological protection, geological surveys, emergency rescue, fire prevention, and many other hurdles before they could finally break through this. The world's longest expressway tunnel. With its completion, the first Tianjin Expressway was born. It cut the drive time from Urumqi to Korla from 7 hours down to about 3 hours. Add to that the Duku Expressway and the Zhaowen Highway, which are currently under construction. And Xinjiang will possess a highway network that reaches in all directions. And connected by this road network, traveling over 3,000 kilometers east from Xinjiang, you can reach any city in China. Traveling over 3,000 kilometers west, you can also reach any country in Central Asia. From this day forward, a great road emerges from the Tianjin Mountains, rising into the vast sea of clouds. This great thoroughfare, which prospered for over 1,000 years after the Han Dynasty, but then after the Song Dynasty, gradually faded from the center stage, finally has the chance to reclaim its former glory.